Hello and welcome to this little video. This video here will be the first part of a series where I try to explain how a relay CPU really works. It's much more simple than you think. And I will start with a simple picture here where you see three examples of relays. Now I want to answer the question, what is a relay? A relay is an electromechanical component, and a relay consists of a coil here, and if current flows through this coil, then it acts like a little electromagnet, and this switch here will switch from one position to the other position. So if I close this switch, current flows through the coil, and the switch here switches its position, and instead of connecting these two pins, these two pins are connected together. And that's all. There is nothing more. It is a controlled switch, nothing more. This is a relay, and instead of only bringing lights, we can switch on and off a second relay. So here we see a first relay, and if I close the switch, the current flows through the coil, the switch is closed, and the second relay switches position. The little video I show you now is showing you exactly this in reality. And if you ever had lessons or lectures about computer architecture, then you know there are three different basic elements for computer architecture. These are the three basic gates: AND, OR, and NOT. And of course, in reality, in a modern CPU, these gates are built from transistors. But here we can build these three gates using a relay, or that's using a diode. Here in this case, these are two diodes. And in an AND gate, only if A and B are active, the output is active. And this is very simple using a relay. With A, we have current through the coil. The switch is closed, and if B is active, then in C we have current or voltage. And a NOT gate is very easy too. If we have here an active signal, then here is nothing. And if here is nothing, then we have an active B. And this is realized very simple. If we have an active current here in A, the coil is active, the switch switches, and our output is 0, no current. I used diodes for the OR gate because it's much easier and cheaper. And an OR gate is if one of the two inputs is active, the output is active. And this is done here. And we need diodes because if we only connect the A and B without diodes, then a current could flow in this direction, and we don't want that. And here you see, this is my last picture for this video, you see how it is possible to store information, to store a number, using relays. The number we want to store comes from here. This is the data bus. These are a set of lines, and using binary numbers, we can transfer information to our little register here. And the main part for storing information using a relay is a relay which is able to hold itself using its own switch. And that's all. If this switch is closed, then 24-volt current is flowing, a current caused by 24 volts is flowing through the switch to the coil. So if this switch is closed, it keeps closed. And that's all we have to know. If here are some lines active because we have a binary number here, and we are setting input enable to active, these coils here will close the switches and the current flows here. And if here is an active signal, this switch is closed. If here is no active signal, nothing happens. And if the switch is closed, it keeps closed. If we open here this, I would say these are the input and output relays. If we are setting input enable to 0 again, no current, then these switches are open. But if here was a signal, then this relay here is closed. No matter what is happening here, this is closed. And if we want to read out the register, if we want to see what information is stored in the register, then we set this output enable to active. Yes and no. These two signals here are, yes, they are the same. This is the same. This has historical reasons why I use two different inputs. Then we set it to 1. This switch is closed. And if this relay here is holding itself, then current is flowing here. If this switch is open, nothing happens here. And so using this, we can store a binary number using relays. We need one relay here to be able to clear the register. If we want to store a new number in our register, we have to clear this register before we can store a new number. And this is done by setting clear to active. Then this switch switches to the empty pin and no current flows here. And if one of the relays is active, it falls. And that's it. And then all our storage relays are set to 0. And that's all. I think that's really a simple thing.